Hello. So, integration is easy. A bold statement to make. So, for a while, let's forget about calculus and talk about more basic arithmetic and algebra. If I gave you the problem statement, 2x is equal to 4, how would you solve this? Well, you would say that's quite simple. You have multiplication on the left, so your solution. Multiplication on the left and a value on the right. Simply inverse of multiplication being division, more specifically dividing by 2 on both sides. So 2x divided by 2 and 4 divided by 2, giving you the solution of x is equal to 2. Fair enough. Can you prove that x is equal to 2? Well, sure. Proof. Let x equal to 2 or sub x equals to 2. You would have 2 into 2 is equal to 4. On the left hand side we get 4, and the right hand side we already have 4. Left hand side is equal to right hand side, therefore proven. Okay, that was simple. We had a problem statement with multiplication. We solved it using the inverse of multiplication, that being division, but more specifically we divided by 2 to isolate x on the left. To prove it, all we had to do was sub in x equals to 2 to give us the answer 4 is equal to 4, and we proved it. We can apply the same logic when it comes to calculus. So, if I gave you the derivative in respect to x of some function, let's call it f of x, and let's say the derivative was x cubed. Okay, so we know that f prime x, so the derivative is equal to x cubed. That's your problem statement. How would you find the original function f of x? How would you find that? This is where integration comes into place. So our solution, what appears to be an elongated s, followed by the parameters with which we wish to integrate. In our case, x cubed, and the respective integration the same way, the derivative in respect to x, the integral in respect to x. This would be read as the integral of x cubed in respect to x. And this one is quite simple. If given a variable raised to a power, all you have to do is take the variable, add 1 to the power, so 3 plus 1, and then divide by that entire statement, so 3 plus 1, which will give you x raised to the 4th power divided by 4 plus c. Well, what's this plus c? This is the constant of integration. Think of it as representing a family of solutions, or more specifically a family of graphs. That may sound a little weird for now, but let's think about something else. Well, what I'm trying to say. I am making the claim that this is equal to the original function, f of x. Can I prove it? Sure. Proof. Let me check if we'll have enough space here. I think I will. So let's just take the derivative of f of x, which I am claiming is x4 divided by 4 plus c. So the derivative in respect to x of f of x is same as the derivative in respect to x of 1 over 4 x4 plus c. This. I just removed the constant 1 over 4 to the left, and I got 1 over 4 x4 plus c. How would we do the derivative of this? Well, it's simple. If you're watching a video integration, you should know your derivative rules by now. All this would equate to is 1 over 4 multiplied by 4x3. And what's the derivative of a constant? The derivative of a constant is always 0. This will end up equating to 1 over 4 times 4x3 is 4 over 4 x cubed. 4 over 4 is same as 1, therefore it reduces to x cubed. there, and there. Proven. So we had a problem statement. We were given the derivative in respect to x of some function, let's call it f of x, and the derivative was something arbitrary. I chose x cubed. How would you solve it? You take the integral, the parameters which you wish to integrate, the respective integration, and this is quite simple. If given a variable raised to some power, the integral is simply that variable power plus 1 divided by the entire statement, so 3 plus 1, so 4. It's the same as saying that the integral is equal to the original function f of x. To prove it, all you do is you take the derivative. If you get that same base answer here and here, it's correct. Let's do one more. If I told you that the derivative of some function in respect to x, this time let's call it g of x, was equal to, let's say, cosine x. How would you solve this? Well, again, solution. You take the integral, an elongated s, the parameters which you wish to integrate, in our case cosine x dx. Now, what is this? The integral is something that to some extent inverses or cancels the derivative. What is the only function that when derived will give us cosine x? If you know your derivative rules, you should know this, that there is only one function when we take the derivative is equal to cosine x. That's sine x. And we always add the constant of integration. Proof. We take the derivative of sine x plus c, which will evaluate to cosine x plus 0, which is just cosine x. Proven. Done. And that's it. So to summarize, think of differentiation and integration as the way you would think multiplication and division. Being inverse of each other, and to some extent they cancel each other. And you can use both to prove the other. And that's it.